All right, we have notes, Chapter 7, Section 5, Part 3, Solving Square Root and Other Radical Equations. And you're going to see here, similarly, when we had equations involving two radicals, these problems are equations that have two radicals. So we're going to use the same process, isolating one of them and using inverse operations to solve. So first isolate, which means get it by itself, the rational exponent term. Raise each side to the largest reciprocal power. We then simplify like we did before. We may need to factor. Use the zero product property, ZPP, setting each factor equal to 0. And solving for the variable. And solve for the variable. All right. Examples, solving radical equations with two rational exponents, two of them. Well, I look at example 1, and I want to isolate this first one. So I'm going to take this second one to the other side. It's negative over here. When I move it to the right, it'll be positive. So I've got quantity x plus 1 to the 2/3 power equals quantity 9x plus 1 to the 1/3 power. You need to keep these in parentheses. All right, so now I'm going to look and compare the reciprocal powers. The reciprocal of 2/3 is 3/2. And the reciprocal of 1/3 is 3, or 3/1. Well, which one's bigger? Well, 3/1 is 3. 3/2 is only 1.5. This is the larger one. So I'm going to take both sides of my equation, and I like to write it again, only in my notes so that I can see what's happening from step to step. You know, a notebook is only as good as what you put into it. So the more you write, the more it is easier to understand. All right, so I know 3/1 is larger. I'm going to do this to the 3/1 power, this to the 3/1 power. All right, what does that leave me with on the left? Well, that leaves me with quantity x plus 1. 2 times 3 is 6. Over 3 is 2. So it's squared. Over on the right side, this is power 3/3, or 1. So it's simply 9x plus 1. Now, if you look here, this x is in grouping symbols. We have to get it out, which means we have to square that binomial, or FOIL and do x plus 1 times itself, x plus 1, which is going to be x squared plus 2x plus 1. Remember, when you square a binomial, it's always a trinomial. Notice on the left I have a trinomial, and I have like terms on the right side that exist in that trinomial. So you have to bring everything to one side. So I'm going to subtract the 9x, and I'm going to subtract the 1. This side's going to equal 0. So what am I left with? X squared, subtract 7x, and the constant goes away. And that's okay. We can still factor this. This is GCF. So I'm going to factor out an x. And now here is where we use our zero product principle, or ZPP. X equals 0. X minus 7 equals 0. So x is 7. So I have two potential solutions. You must check these. You have to check all radical equations for extraneous solutions. We're going to go into the original. I like to set it up. I'll put a parenthesis here for x. So there's my x plus 1 to the 2/3 minus 9 times x plus 1 to the 1/3 equals 0. And I'm going to do this twice because I have two solutions. So parenthesis for x plus 1, subtract parenthesis for x plus 1. And now I'm going to insert my solutions. The 0 first in both places. And then the 7 in both places for the second check. All right, what's 0 plus 1? 1. This is the cube root of 1 squared. Cube root of 1 squared is 1. All right, cube root of 1 is 1. Square the 1, you still get 1. Folks, guess what? This is the same thing. 9 times 0, order of operations. 9 times 0 is 0 plus 1. Cube root of 1 is 1. This becomes 1 minus 1. And that is a true statement. The second check. 7 and 1 is 8. Cube root of 8 is 2. 2 squared is 4. 9 times 7, 63. Plus 1, 64. Cube root of 64, 4. 0 does equal 0. So because both solutions work, I conclude that I have two solutions. X is 0 and x is 7. So if you have questions on that, please ask. All right, let's take a look at example 2. If you want, you can pause the video and try this one on your own. I'll work through it with you. But if you're confident, it's the same type of problem. Look at the exponents are the same, 2/3 and 1/3. All right, so I've got 4x plus 3, 2/3 power equals, I'm going to move this over, 16x plus 44 to the 1/3 power. I'm going to do a comparison again. The reciprocal of this is 3 over 2. The reciprocal of that is 3 over 1. 3 over 1 is larger. So that's the thing you have to remember here. You have to remember to raise it to the larger reciprocal, not the larger fractional exponent, the larger reciprocal of that. All right, so what do we got here? 4x plus 3. Multiply the exponents, you're going to get a 2. Over here is 16x plus 44. The exponent there is 1, right? 1/3 times 3 over 1 is 1. Foil this out, or square the binomial. Square the first term, 16x squared. Square the second term, plus 9. You multiply those two and double it, you get 24x. Or foil it out. It's quadratic, linear, constant, bring those over. 16x squared, 24x, subtract 16x is 8x. 9 subtract 44 is negative 35. Factor So here comes back our factoring into the HA2. I won't go through the process again. I'm just going to factor it. I'm going to check it to make sure that my factors that I chose work. 7 times 5 is 35. Doesn't matter where I put them because these are both 4x. Signs are not the same. Larger product is positive. 28, 20. So positive goes here, negative goes here. Check it. Those two 4x's multiplied with each other give me 16x squared. Plus 28 minus 20 is plus 8. 7 times 5, 35. It's negative. It's correct. ZPP here. X equals, you're going to add the 5 and divide by 4. The ZPP here, you're going to subtract the 7 and divide by 4. I have to do a check for both of these. So here's my 4 space for x plus 3. Raise to the 2/3 power, subtract 16 space for x plus 44, 1/3 power. Set it up again. Okay, we've got fractions this time. And that's okay. Negative 7 over 4, negative 7 over 4. All right, let's take a look at this. You might want to be reaching out for a calculator, but I'm not sure that you really need to. This 4 is in the denominator, that one's in the numerator. They're going to divide out. This becomes 5 plus 3, which is 8. Cube root of 8 is 2, and 2 squared is 4. Minus. Again, the 4 will go into the 16 4 times, and 4 times 5 is 20, plus 44 is 64. The cube root of 64 is 4. So sometimes it's just easier and faster to not use the calculator. The second check, again, the 4's are going to divide out. This is negative 7 plus 3, which is negative 4. Let's see, negative 4 cubed. Well, let's do, this becomes negative 4 2/3 power. And let's see what this is going to give me. Because for this one, you might want to use a calculator. I don't know. When it doesn't work out to be a perfect cube. You know, 4 is not a cube. All right. 4 goes into 16 4 times. 7 times 4 is 28. It's negative 28. Excuse me. Plus 44. Oops. Is 16. So this is the cube root of 16. Well, look at what I have here. Negative 4 squared is 16. This is the cube root of 16. And so is this. And that does equal 0. Okay, so I just converted it, right? The negative's on the inside, so the squaring applies. That's positive 16. So that's the cube root of positive 16 minus itself. It does work. So because they both work, I conclude that x is equal to negative 7 over 4 and 5 over 4. But again, you must check them. If you have questions, Please, please ask. All right, side 2. Additional examples. Now we see radicals inside radicals, but that's okay. Don't let it scare you. I do have one of the radicals isolated already. So I'm going to get rid of the radical symbol around the outside. I'm simply going to square it. So I'm going to copy the problem down. X plus square root 2x equals square root 2x. To get rid of the first radical symbol, I'm going to square, but if I do that on the left, I have to do it on the right. This squaring removes the outside radical, so I'm left with x plus the square root of 2x equals 2x, right? Because this squaring is going to remove that radical. My next step is to combine like terms. I'm going to take this x over here because my goal is to isolate this radical. So I could do the squaring again on both sides. So I have the square root of 2x equals 2x subtract x. Folks, if you're not going to write all the steps down, it's fine, but then you need to have a dialogue in your head so that you know you subtract. I'll get students that add these. You can't add them. You're subtracting x. So 2x minus x is 1x. Now I'm ready to square both sides again. The left side gives me 2x, and the right side gives me x squared. It's quadratic. I'm going to take everything to one side. 0 equals x squared, subtract 2x. It's more beneficial if you keep the x squared term positive instead of subtracting the x squared over. This is GCF factoring. X times quantity x minus 2. ZPP says x is 0 and x is 2. But we have to check these because they are radical equations. So I'm going to set up what I have here. Two times. All right, now I'm going to substitute in my values of my solutions. 0, 0, 0, 2, 2, 2. All right, this one should be easy. 0 plus square root of 0 is 0. This whole thing is 0, equals 0. And that one works. This one, a little more thinking, not too difficult. 2 times 2 is 4. The square root of 4 is 2. 2 plus 2 is 4. The square root of 4 is 2. This is the square root of 4, 2. So because my checks work, my solutions are 0 and 2. All right, next example right next door. Again, if you want to try this on your own, you can. Well, maybe I wouldn't. Maybe let's do number 2, and then you can try number 3 on your own. So, I'm going to keep the bigger radical. No rhyme or reason. It's just what I do. One of them has to go to the other side. And you're going to take this one over by subtracting it. Okay? It's positive on the left side. So this is going to become 5 subtract the square root of x. Now I have one of the radicals that is isolated, and you need to square both sides. Now what you need to remember is on the right side, that's a quantity and it has to be squared. You're going to have to FOIL that out. And sometimes foiling with the radical, I don't know, sometimes students have issues with that, but hopefully you won't. X plus 5 on the left equals, write this out as a FOIL if you want to, if it's easier for you. Okay, you can write it like that. 5 times 5 is 25. Right, I'm multiplying these two. Can't really see it with a pencil. All right, 5 times 5, 25. This is going to be 5 times negative root x is negative 5 square root of x. And again here, negative root of x times 5 is the same thing. And then here, negative times negative is positive, and that's the square root of x squared. All right, let's simplify that. X plus 5, 25, subtract 10 square roots of x. Well, the square root of x squared is x. This thing is not quadratic, and I do have a radical still in my equation. I have to isolate it, which means I have to take this and this to the other side first. So I'm going to do minus x minus 25. All right, minus x minus 25. What's left on the right side? Negative 10 times the square root of x. What's on the left side? Well, that's going to go away. 5 subtract 25 is negative 20. I can switch sides to make them positive. I didn't have to do that. You can square both sides right here and now, or if you realize that 10 divides 20, you can divide that right away. It doesn't matter, but it gets you a little bit of trouble when this number doesn't divide that number. So hopefully you're listening to the video and not just watching it with no sound, because that's not going to help you. So I'm going to opt to divide it. So I get the square root of x equals 20 divided by 10 is 2. Now I still have a radical, so I have to square again. And I see that x is equal to 4. But I have to check it. You must check. Square root of x plus the square root of x plus 5. Does that equal 5 when x is 4? Well, this here is 2. Plus 4 and 5 is 9. Square root of 9 is 3. Yes, it does. So I conclude that my solution is x is 4. Okay, why don't you try the next one? Pause the video. I will say that a trick with these types is when you have a subtraction sign here, yes, you're going to add this one to the other side to make it positive, but I would bring the 2 over here so that you have something smaller when you're foiling a binomial. Okay, that's just a little trick. You can switch sides with those two. This one will become negative and this one will become positive. So why don't you go ahead and finish the problem. Pause it. Okay, if you pause the video, great. Hopefully you were able to walk through the steps. Here I have the squaring on both sides. When I FOIL this out, I get square root of x squared, right? Square root of x squared minus 2 plus 4 equals x minus 2. When I combine the middle terms, I get minus 4 of those square roots of x. This thing squared is x, and the 4 stays. I take the x and the 4 over to the other side. I end up with negative 4 times the square root of x equals negative 6. Divide by negative 4. Square root of x equals negative 6 divided by negative 4, which simplifies to positive 3 over 2. Square both sides. X is equal to 9 over 4. But now when I check this, okay, I set up my check. Square root of 9/4 is 3 halves. Now, inside 9 over 4 minus 2, well, I have to convert this to fourths. This is 8 fourths. 9 fourths minus 8 fourths is 1/4, and the square root of 1/4 is a half. Now look at this. 3 halves minus 1/2 is 2 halves, or 1, and 1 does not equal 2. So there's no solution to this problem. So it's really, really, really important that you are checking for extraneous solutions. Okay, one more to do. Well, I see something with a rational exponent. That's quantity x minus 1 being raised to the 4 over 3 power. And then there's a 4 behind it, so it's adding 4. So, folks, I need to subtract the 4 first and then divide by 2 because you have to isolate this. This has to be isolated. All right, so I got 2 times quantity x minus 1 to the 4/3 equals 36, subtract 4 is 32. Divide by 2, quantity x minus 1 to the 4/3 power equals 16. Raised to the reciprocal power. There's only one. I don't have to determine which one's larger. There is only one. So I'm going to raise this to the 3/4 power. Now look what we're doing. We're taking an even root. And when that happens, you need to use plus or minus. All right, the left side is simple. It's x minus 1. Has to be. That's why we did this, to get rid of that, so we can get that. The right side is plus or minus. Well, think about it. What is the 4th root of 16? If you don't know, type it on your calculator. The 4th root of 16 is 2, because 2 to the 4th is 16. And then you have to cube the 2, and you get 8. Now, we can't just do add 1 and get plus or minus 9. You can't do that here. It's kind of like when we're working with a quadratic formula. You have to set up your two cases right here. X minus 1 is positive 8, and x minus 1 is negative 8. This is not ZPP. This is just setting x minus 1 to first the positive case and then the negative case. So be cognizant of that. All right, now you're going to add 1. X is 9. Now you're going to add 1. X is negative 7. Okay? Now we have to check them. All right, 2 parenthesis for x, subtract 1, raised to the 4/3 power, add 4 equals 36. I have 2 solutions, so I need 2 checks. First solution is 9. Second solution is negative 7. All right, again, you can use the calculator to aid you, unless you know your order of operations. 9 minus 1 is 8. Inside the parentheses is 8. This cube root is applying to this 8 only, not the 2. Right? Cube root of 8 is 2. 2 to the 4th is 16 times 2 is 32. Plus 4 is 36. It works. Negative 7 minus 1 is negative 8. Folks, the cube root of negative 8 is negative 2. Negative 2 raised to an even exponent is going to be positive. This is positive 16 times 2 is 32 plus 4 is 36. That works as well. So, because both of my checks work, I conclude that x is 9 and x is equal to negative 7. Okay, so if you have any questions, please ask in class, or if you are at home, pop into a Google Meet or post on the homework discussion, and let me know if you have any questions so I can help you. Have a great day.